Dear ladies and gentlemen, we are very excited to welcome you all here today in the deep space at the Ars Electronica Center in Linz. My name is Gernot Paulus. I'm professor for Geoinformation at Terrestrial University of Applied Sciences in Villach, Austria. And on behalf of our interdisciplinary project team, I will guide you through this presentation today. We are here at the end of a long and also quite emotional journey full of coincidences, which almost started exactly 1 year ago with a project in Klagenfurt in Carinthia in the south of Austria with a real forest in the middle of a soccer stadium. This project for forests not only created worldwide attention, also not only in the art world, but also really provided very challenging opportunities for science in the field of geoinformation, surveying, forestry, and also the digital transformation of nature into a virtual space. We also invite you to join us today to explore this area of tension and transformation between art and science from different perspectives, from the artistic perspective, from the science and technology perspective. But last but not least, we also are very excited to explore with you together this project for forest for the very, very first time, a world premiere, so to speak, here today into the deep space. We are also very, very grateful and happy to welcome a visionary mediator of contemporary art, the creator and actually the brain behind this very unique For Forest project, who will share with you the artistic background and the visions behind this project For Forest. So please welcome Klaus Littmann.
Yeah, what can I say? I have to tell you a little bit about this project. The story is very long, and I try to do it in a short time. And I have to excuse also my bad English. But if I would speak with you in Swiss German, you wouldn't understand nothing. So I try my best. Where is this point? Yeah, I'm realizing since many years projects in public space, and this project is one in a long, long line, but it is also for me the biggest that I realized till today. It goes back for me that I saw 30 years ago in Vienna. A friend of mine showed me a drawing of Max Peintner, this Austrian artist and architect. And he showed me this drawing, and I was in that moment really completely, in a way shocked. Where I saw this idea, this image, and the title of the drawing was also for me very, very nice and beautiful, The Unending Attraction of Nature. And I was totally fascinated because I heard that he made this drawing 1970 and 71. So that means 50 years ago. And I saw it 30 years ago. And when I saw it, I had directly the idea that I want to try that this project will be real, that we really can see it in real. And I was fascinated because that somebody in 1970 has the idea that it could come in the future that we go, when we want to see nature, that we have to see them in specific places like here, like in a stadium. It took 30 years because to find a stadium is not very easy. Everywhere in France or in Switzerland or in Germany where there was a discussion that maybe they build a new stadium, and I did go there, but you have no chance, because when the soccer club plays successful, then you have no chance to get in, because there's so much money involved. There was no chance. I had another project in Basel where I'm living, and there was involved also a young colleague from me, a young artist from America. And one evening I was asking him what he did before, and then he told me he was in Klagenfurt, and he made there also very nice project in public space. And then he showed me a photo of this, and in one photo there I was asking, what is this here in the back? And then he told me, yeah, this is the stadium from Klagenfurt. First, I didn't know really, you have to excuse me, I didn't know where Klagenfurt is really. And when I saw the stadium, I said, "Boah, they have a stadium like this is incredible." And then he told me, yeah, but it's also a political story and a long story. And he told me also that this stadium is used by a soccer team, but they are not in the best shape. So when they have a game, maybe 400 or 500 people coming to see the game. And then I said, yeah, for this I'm looking now since 30 years. So what I did go directly by car to Klagenfurt to see this stadium. And then 6 years long, I did go many times to Klagenfurt. I spoke with all the different people in politics and whatever. And after 6 years, we could open this project last year on the 8th of September, so directly 1 year ago. If you want to realize something like this, you need money, of course, because it's a really very expensive project. So I had to organize the money, because the whole project is paid by private money. The biggest part of it I found in Switzerland, and then you need also to have the people where you can do it. So I found a very good landscape architect, Enzo Enea, in Zurich, and I showed him what I would like to do, and he said, yeah, it's a must, we have to do it. And then he organized what we needed, because first it was important for Max Peintner also that we have a forest where we have mixed trees, not only one type of trees, that it will be a mixed tree forest. The other thing was that it was important that you couldn't go into the forest, or you couldn't touch the forest. So the people, like here, watched it from these different levels, and that was also for me important, that when the people did come to the stadium, that they really walked around, that they did go up and down and saw it in different perspectives. We needed 300 trees, because the whole field is about 7,200 square meters. And these trees we found not in Austria, because what you need for that is, I don't know what the word in English is, it's called verschulte Bäume. It means these are trees, you have them in a package, and every 4 years you have to plant it in a next size, so that you have really trees in the size of about 40 meters. So these trees that we used, they are all between 30 and 40 years old. And there you have specific places in Europe, in Italy, in Germany, in Netherlands, where they bring them up. So we did bring them all to Klagenfurt. And there, in the first moment, I had my personal problem, because of course, I was thinking, yeah, is this really, can you do that? That you take trees so many kilometers to a place to show the people what could be in the future. But we decide yes, because this picture is of course, or this image is of course also a provocation. And sometimes you, yeah, I think it is very important that you realize or show the people this, because we all in our daily life, yeah, we're going around, and with the time we don't, yeah, see or realize what's around. And what we're doing here was something very simple. We took something from daily life, a forest, and we put it in a different place where you couldn't accept that this is there. And the reaction of the people was really amazing. I never saw so much people crying when they saw these trees in the stadium. It was also for me important that, or for me it was clear, but it was a big discussion, because everybody said, yeah, but why are you doing this? And then I said, yeah, it's important. I'm sure that this image will go around the world, and this was happened. And then there was something else coming, and that was for me also luck in one way, because with Friday for Futures, for the people, they had also a different view. I mean, for many people, the forest is just something symbolic. It's a place of happiness, but this is also a memorial for the whole climate change situation. But that this was happened in this moment. I mean, a drawing was 50 years old, or an image that was 50 years old, that we could realize it in this time last year. That was really, yeah, incredible. I'm really happy that we could realize it. And then something will happen, that these people did come from the Fachhochschule or university in Kärnten, and they told me, yeah, we want to go in the stadium, and we want to do this and this and this. I didn't understand anything, and I must tell you, till now I don't understand it. But yeah, I will be also surprised now what we will see, or what I will see. It's something for me, something, yeah, where I never was thinking that something with this image, you have another step in a time or in a future or in a completely new field. And yeah, I thank you for that. And now I will be really wondering what I will see.
Yeah. So these are just actually the starting point. I don't know. Maybe some of you have already seen this project one year ago. These are actually different types of impressions. It was really spectacular. It was also open till 10 p.m. at night. It was from beginning of September till end of October. You also can see changing of the colors. So many people visited it from at different times. People came in to have a picnic, and this was really a very special and unique also from a personal point of view. And as Klaus Littmann already said here, a lot of people were really touched by this worldwide very unique project. Also in the combination with this very nice architecture of the stadium and the different visions and views. This has been really very interesting. But this what you see here now are just pictures. Everybody of you can actually take it with a smartphone, with a camera, and what were interested in was actually also the scientific perspective of this project. So for us, suddenly we had this forest in a stadium, and from a scientific perspective, actually this represented for us a worldwide unique experimental lab where we have controlled conditions, we know how many trees are there, which type of trees are there, and the questions we are interested in were on the one hand, how can we handle this large amount of data capturing from the real world and transfer it to a digital space. We are using different sensors. On the one hand, on the ground, terrestrial laser scanning. How can we combine those with data we get from aerial images of drones at very high resolution? A very interesting question is also how accurately can we represent green space and vegetation in a virtual space? And what we will also do together here, how realistic can such an art intervention be documented, which is over in the past, but maybe also to present it to future generations, and how we can experience such things together in a virtual environment. And the making of this project, or the data we will see at the end, we will just go through. So the first thing is actually the vertical view. Here we used drones, what you can see here. It's a fully certified professional multi-rotor system with a high resolution camera. What you can see on the left-hand side, the stadium and the mission plan. The drone is flying this path based on GPS automatically. And what we will get here is some technical parameters. In total, we have about 570 individual images. They have a very, very high overlap, an incredible resolution, about 6 millimeter per pixel. Flight altitude was about 70 meters. And based on this high overlap of these pictures, we can then create different type of data from the vertical view. One are so-called auto images. In these images, they are rectified, and we can also measure there. And you can see here also the different resolutions. And one product we will explore at the end today are so-called 3D point clouds. We have here the same point, for example, a leaf of a tree in different images, and from the different angles we can calculate the 3D position of such a point. And here you can see now the representation of this forest, not only in an image, but represented by about 800 million individual points and the data size of about 20 gigabyte just of this data. And this is just a few we have from above. And then, of course, we cannot see everything from above. We also need to go into the horizontal view. And here we are using terrestrial laser scanning. And my colleague, Philipp Zebedin from Leica Geosystems, he will now actually explain you this part here from the ground.
Thanks, Gernot. Okay, I had 3 tasks in this project. The first task was to capture the terrestrial points, so the laser scanning from terrestrial view, to get a lot of information from the ground. That you can have an overview what we did. We used 2 laser scanner, 2 teams, and it was really hard to get all the information done in a very small time period. As you can imagine, on the one hand side, the forest has to be ready, but on the other hand side, there should no people inside the stadium, that they are not also captured on the point cloud. So we get 4 days to collect the terrestrial data, and the first day we went around the stadium, outside the stadium. On the second day we went inside the stadium, but inside the building of the stadium. And the last 2 days we were inside the public area. So you see it here, we went up and down nearly every rank, every level of the stadium. And what was in the end a very big bonus, Klaus Littmann allowed us to enter near the forest. So as you can see here, we are very close to the forest, and so we get a lot of information also inside the stadium. We had nearly 600 setups. One setup is one standing of the scanner, and this was a lot of working. It was also the outside working, but also the they're working on the computer. It took several weekends to calculate, to process this data, and this is one of the first results. So you can see also outside we get a lot of information, but also, of course, inside of the stadium. The laser scanning point cloud has nearly 27 billion points. So the second task I had to fulfill is then to make a fusion between the data, the point cloud from the UAV, from the top view, and the point cloud from the terrestrial laser scanning. And I have to be honest, I've never done this before, so this was also very exciting for me. It took, I think, 2 weeks that I get the first impression of the compared point cloud. And now was one question was, is this correct? How can I prove if the 2 point clouds are correct? So with Gernot we thought, what can we do to compare, to validate these point clouds? So we took 3 examples from the whole point clouds. One is the building, as you see on the left-hand side. So we took stairs built of concrete. Then in the middle some clearing. This was directly in the middle of the forest. And of course the forest, we need some trees. So we took one example of one tree to make some comparison. First, I took the different sensors and made the point clouds in different colors. So as you can see here, the red dots are points collected by the terrestrial laser scanning, and the green dots are from the UAV, from the drone. Okay, on the left-hand side is the stairs. Most of the points were collected by the terrestrial laser scanning, because this concrete are under the roof of the stadium, so there was no chance to get some information from the photos taken from the UAV. In the middle it is, I would say, half green, half red, and what was the main part and why we choose both sensors is because of the trees. You can see here, up in the trees, there are a lot of green points. The most green points, there's a really big part of the green points that they will come from the drone. That's what it is. We took it from above. And on the ground there are no green points. So that's why we took the second sensor and we collect the data from the ground, from the terrestrial laser scanning, and with the fusion we get an overview of the whole tree. So, but that is no answer of our question, is this correct or how accurate is this tree? So what was the next step? The next step is we made a difference picture. We said, okay, we will compare the both point clouds. How big is the difference from the drone point cloud to the terrestrial point cloud? And the biggest part is around 3 centimeters. That's much better than we expected. This is in the middle, in the clearing, and that's of course because I told you before we have no overlap in the lower part. There we can make no difference, but in the upper part of the tree you can also say in this histogram the biggest part of the point difference is around 3 centimeters in 3D, not only in the height, or in 3D. So this is really a great result. We never thought that we can get it so accuracy, and we're really happy about this fusion. So here are some specs about the fusion, about the complete 3D point cloud. Yes, you can see here nearly 27.5 billion points used here for control. For control and registration, we took 10 control points, and here the accuracy is 8 millimeters and 12 millimeters to a normal surveying. So this is really, really great. We never thought that we can get this. So now I'm at the end. I will hand over to Gernot, and I wish much fun to view now our point cloud.
Okay, so just the final step actually was done by our colleagues from the Ars Electronica Future Lab to take this point cloud, what we created, this integrated point cloud, and transfer it here into the deep space, into this virtual environment. This work was done by Roland Haring and Roland Eigner. And we are going now to dig into the deep space and the view of the stadium now. So you have to put on now your glasses, your 3D glasses. Okay, so what we have done here now is just to define some specific points. So we are just starting with a flyover on the roof from the different sides here, with a look at the bird's view into the stadium and into the forest from above. We are actually also now coming to the ground and entering the stadium through one of these entrances. So you can also see this information, this combination from terrestrial laser scanning, or the infrastructure, the beams inside the stadium. And these are now actually some of the views the visitors actually just were able to make and experience, walk around the grandstand from below, from above. Actually, there are 30,000 people in the stadium, so it's really, really, really huge. And so what you can see here also, again, as I said, this infrastructure and these perspectives of the stadium. Here are also some people actually were visiting, which were also captured. And now we are also here very, very close at the grass, actually, where normally football players are warming up. And this was here also the close-up view. And then again, we have here this view again from above. And here, this is actually also this clearing. This was actually not possible to access for the people visiting. And also what you can see here are the different layers of vegetation: the grass on the one hand, and the low bushes, the ground, and the tree stems. You can also see here in front some deadlock, which was also placed there to really provide the impression of a real forest. So only animals like deer were missing. But here, this is something which was, for example, not possible to explore during the project here. But now in a digital environment, we also have this chance to view and have this still impression available. So this was now actually this predefined path through this point cloud. And I would just ask Katrin now, because she is, I think, much more experienced in using such a console for a free flight actually through
So the thing
stadium.
is that not only I am gonna show you a free flight, but if anybody wants to try it out on their own, that would also be possible. So that's the idea. I'm gonna show the person who wants to try it how to use the Xbox controller. It's quite easy, so don't hesitate. Would be fun if somebody else wants to try it as well. Yeah, you? Perfect. So it's quite intuitive, and that's also the positive for this technology. And while you can try that one out, are there any questions from the audience to either Herr Paulus, Herr Zebedin, or Herr Littmann? Mr. Littmann? Or does anybody just want to enjoy for now? Over there?
Where are the trees now?
Okay, who would like to answer that one? Herr Littmann, maybe?
Yeah, the trees now in different places. The original idea from my side was that the forest will be planted nearby the stadium in Klagenfurt, but in the end this was not possible. So some of them in Ober- or Niederösterreich and some in Klagenfurt, but they are not together anymore. So this forest is not existing in that way how you can see it now here.
But it's still existing in the virtual space. So as it was, so as we have measured and located and captured the data, so we still know exactly which tree at which location and which species is still there. So at least in the virtual world, it's still together.
So because we are right now at the clearing, I have actually a question also for you. Why did you put a clearing in if it was never your intention to have people walk around in the forest?
Yeah, that was from beginning on clear also from Max Peintner's side, because what we wanted is that the people, they go in the stadium, walking around, like I said before, but then also we wanted that the people, yeah, maybe sitting down and look at it, have a respect distance, and that they maybe start to think about what has this to do with me? What is my relation to the nature, to the forest, and all these questions that came up when you saw that. That was also something that the people told me. Because when you're going in a forest, yeah, like once in a week or more, yeah, you have not this distance and not this image that provokes you to think about that what you see in a clearer way maybe.
Thank you. And would anybody else like to try the application out? So you flew us around quite well already, but maybe somebody else, because there are quite a lot of people in here, would like to try it? We hear somebody? Because otherwise you can continue if you want to. Yeah? Okay, so if there aren't any further questions, we can just enjoy the forest for a moment. Hang on 1 second.
For how long did you keep the forest?
2 months.
Okay, so for 2 months. Yeah.
What are you doing now with this material in the future?
What you see here now was actually really the very first achievement to bring this forest with a 3D point cloud here into this 8K virtual environment. One of the challenges we have still is that on the one hand we have the whole project with about 27 billion points, but we have here a bottleneck in this transition into the deep space just due to computational power, that, for example, a smooth rendering like you see it here now is possible. So this is something we are interested in the future also to bring in much more information we have already also into this 3D world. What you can see here now is vegetation, is a forest, but also in the future it might be possible to explore such a vegetation for a forester to do some measurements in this virtual space. So what we did also as reference measurements was that we not only located every single species at the exact location in the stadium, but we also measured, for example, the stem diameter. This is a measure foresters are interested for harvesting. And as we have this reference data, we can now see how accurately we can extract out of this combination of terrestrial laser scanning from the ground and drone images from the air an automatic process for supporting a forester to harvest. So we have 2 student research projects performed so far successfully. So it's a incredible data set we have available. Also to continue working on getting metrics out of, for example, an automatic calculation of the height of the canopy. And if we can prove that this will work here, we can then in the future also try to reproduce it and do an automatic change detection. So how is our environment changing, also in terms of climate change? Not only having here the morphological parameters, but also how is the tree changing over a whole vegetation period. So these are the questions we are interested and we are currently working on.
Okay, so I think we flew for some time now over the forest and also through the forest, of course. And I would like to thank you also, Mr. Paulus, thank you so much, Mr. Littmann, and also Mr. Zebedin, for us to be able to have this project here in Deep Space 8K. And of course, I would like to thank all of you for attending this year's festival. And I hope you enjoy your further stay here very much. And maybe also once again in the deep space. So thank you, and when you go out, would you please put your 3D glasses into the boxes? That would be great. Thank you.
Also, thank you very much from our side. Thank you.